All right, everyone. So this is actually the last PowerPoint that I'm making for you for the whole entire year, which is nuts to me. I cannot believe it's already June and that the year is almost over. So we're just going to review for our Chapter 11 test today. We'll do a little bit more review in our meeting on Thursday, and then you'll take your Chapter 11 test on Thursday, or you can take it all the way up until Friday, and then that's that, and our school year is over. So our first, well, this is actually the only problem. There's kind of two parts to it. So this is one a review problem that I go over a lot in class normally if we had real like in-person class, which obviously we don't. So I just want to touch base on these types of problems and give you guys a little bit of time to practice. So I've got two slides where I'm going to go over both the surface area of this figure and the volume of this figure. So I'd encourage you to like pause right now and try it by yourself and then go walk through the next few slides with me as I go over it. But try it by yourself first and just see if you kind of line up with everything that I describe in the next couple of slides. All right, so the first thing we want to do is find the surface area. Again, if you haven't paused, please do and try this out by yourself. And if you want to even zoom to the very end of this section and see if you just got the answers right and then go back to this part, that's fine with me. But for the surface area, this figure right here, it looks like we have a cone on the top and then cylinder on the bottom. So we have formulas for the surface area of a cone and formulas for the surface area of a cylinder, but we don't really have any formulas to represent composite figures, right? So we kind of just have to use our common sense for surface area. Um, so when I'm looking at this, what I see is that there's like a base on the bottom, right? I'm trying to think of if this was a solid figure, where would I be painting it on the outside of the figure, right? So I could paint the bottom of it, and I could paint around the outside of the cylinder, and I could paint sort of the like slant height sides of the cone. But this circle that's in here, I actually am not going to be able to paint that, right, if this was a solid figure, because this would be on the inside of the figure, right? So this is kind of here to help us visualize the base of the cone, but this circle right here is not actually on the exterior of the shape, so it's not going to be included in the surface area, which this is the part that kind of throws people off sometimes. So if you need some help, keep watching. So I went ahead and highlighted that base. I know that's kind of a terrible highlighting there, but we do need to know this base in order to find the surface area of the cone, right? So remember that the formula for the lateral area of a cone is 2 pi r, that's the circumference, times the slant height, L, divided by 2. And then we said, oh, those 2's can actually cancel out. So a simplified version of that would be pi times r times the slant. So I went ahead and found the lateral area, but before I could find the lateral area, I needed to find the slant height, right? So I have the actual height of my cone here, and I do have the radius, it's 9 from the bottom down here. I don't have the slant height. So 9 and 12, I used the Pythagorean theorem, our trusty friend, to find the slant height. So I found that the slant height was 15, right? 9 squared plus 12 squared equals L squared. You also might have noticed 9, 12, and 15, that's a 3, 4, 5 triangle multiplied by 3, right? 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. So either way, you should find out that the slant height is 15. And then we can find the lateral area by saying pi times r, which is 9, times the slant height, which is 15. The lateral area is 135 pi centimeters squared. Now, I'm not going to bother finding the base of the cone and adding it to get the total surface area of the cone, because I can see here that this base is not on the outside of the shape. So I'm just going to ignore that for now, right? All I've found so far is the lateral area, or kind of the sides of my cone. Next, I want to find the lateral area of my cylinder. So around the sides of my cylinder, I know that that formula is 2 pi r, the circumference, times the height of the cylinder, which here is 18. So just plug that all in. There's my base that I highlighted. The radius is 9, so 2 pi times 9 times the height, which is 18. That gets me 324 pi centimeters squared. So far, I found the lateral area of the cone and the lateral area of the cylinder, and then I just need to find this blue base that's down here, because that kind of caps off the bottom of my figure. So since we only have one base, the area of the circle is just pi r squared, or 81 pi centimeters squared. So now, in order to find the total surface area, it's going to be the lateral area of the cone, the lateral area of the cylinder, and then just that one base down here on the bottom. The green circle is not on the exterior of the shape, right? So I cannot include that in my total surface area. Otherwise, I'd have a little bit too much surface area. I'd have too many extra bases. So if I add those guys all together, they do all have pi right next to them. So I can just add together the numbers, the coefficients of pi. and say that this total surface area is 540 pi centimeters squared. And I'm just going to leave it with the pi and not multiply it out for now. So now to find the volume, remember we said when we had a prism, right, we could kind of find like the composite base that works for the whole figure. Well, if I look at this shape, there is one base, right, the circular base that is the base for the cone and it's a base for the cylinder, but my height isn't the same for the whole shape, right? My height of my cylinder is 18, the height of my cone is 12. And so using just one base and multiplying by the whole height isn't exactly going to work here. So I am actually going to split this into a cone on top and a cylinder on bottom. Again, just like with surface area, you kind of just have to use common sense in these composite figures. So the total volume is going to be the volume of the cone plus the volume of the cylinder. So obviously I need to find both of those. My base area, remember we need the base area for both cones and cylinders. The base area we already said from the last slide was 81 pi centimeters squared. The formula for a cone, for the volume of a cone, is pi r squared times the height divided by 3. So for my cone up here, the height is 12, right? Pi r squared was the 81 pi, right, the area of the base. So it's going to be 81 pi times the height, 12 divided by 3. That gets me 972 pi divided by 3, if I just multiply these top numbers here. And then 972 is 324. So my volume of my cone is 324 pi centimeters cubed. Did you remember to cube your units there? And then for a cylinder, we know that the volume is basically just base times height, and base is pi r squared, so 81 pi. So my height of my cylinder is 18 centimeters, right? So it would be 81 pi plus, or sorry, times 18, which is 1,458 pi centimeters cubed. So now I'm just going to add those two together. 324 pi plus 1,458 pi. That gets me a total of 1,782 pi centimeters cubed. And remember, we want to have cubed units because it is volume. That's all. We are done with lessons for the year, which is so crazy to me. Your assignment is to do your Chapter 11 test review worksheet. I made an extra worksheet for you as well, which is optional if you want to. It'll be some really good practice and review for the test. And then I'll see you guys in our lesson on Thursday, and we'll take the test, and then we will be all done for the year. Woohoo!